Right now, a particle called Amaterasu is still arriving, still slamming into our atmosphere from a direction in space that holds absolutely nothing. And NASA, the telescope array team, and the sharpest minds at the University of Utah have no way to stop it, trace it, or explain where it came from. But here's what nobody is telling you. On May 27, 2021, something hit Earth's atmosphere that had no right to exist. It was a single subatomic particle smaller than an atom, invisible to every instrument we have, but it carried the energy of a brick dropped from a skyscraper. Not light, not radiation, a particle, one particle, traveling at 100% the speed of light. Scientists named it Amaterasu after the Japanese goddess of the sun, and the name fits, because just like staring directly at the sun, the more you study this particle, the more it blinds you. The telescope array experiment in Utah, one of the most sensitive cosmic ray detectors ever built, caught it. Spread across 700 square kilometers of open desert, 507 surface detectors lit up simultaneously. They had their data. They had their numbers. What they didn't have was an answer. Here is what they measured. Amaterasu arrived with an energy of 240 exaelectron volts. That number means almost nothing until you compare it. The most powerful particle accelerator humans have ever built, the Large Hadron Collider at CERN, fires particles at roughly 13 tera-electron volts. Amaterasu hit our atmosphere with approximately 20 million times more energy than that. One particle, no machine, no visible source. And there is a rule in physics called the GZK limit. It says any particle traveling with this much energy cannot travel more than about 160 million light-years before the universe strips that energy away. The cosmos is saturated with background radiation, and it acts like a wall. So whatever fired Amaterasu had to be relatively close, cosmically speaking. Close enough that our telescopes should see it. Close enough that we should be able to point at it and say, there. When they pointed, they found nothing. And what scientists discovered at the end of this search is the part they're afraid to say out loud. The obvious explanation is a dead star, a gamma ray burst, a supermassive black hole firing a jet directly at Earth. These are the known engines of ultra-high-energy cosmic rays. Active galactic nuclei, galactic cores with black holes the size of solar systems, are always the prime suspects. Scientists backtracked Amaterasu's path across the sky. They drew a straight line backward through space and asked, what is there? A void. An empty region called the local void, where galaxies thin out and the large-scale structure of the universe simply drops away. There is no active galactic nucleus in that direction. No neutron star collision residue. No gamma ray burst signature. No known object powerful enough to do what was done to that particle. But here's the strange part, it shouldn't be possible at all. And this is where it gets deeply unsettling. The oh my god particle, detected in 1991 over Utah by the Fly's Eye experiment. Energy of 320 exaelectron volts, still the most powerful cosmic ray ever recorded. Its source was also untraceable. Scientists spent decades searching. They found nothing definitive. And then the community quietly moved on, half assuming it was a fluke, a measurement anomaly. An outlier the universe would not repeat. Amaterasu repeated it. Two particles, separated by 30 years, both arriving from directions in the sky that trace back to voids, both carrying energies that should be physically impossible to sustain across the distances implied, both pointing at nothing. The telescope array team published their findings in November 2023 in the journal Science. They wrote that Amaterasu challenges existing notions of the sources and propagation of ultra-high-energy cosmic rays. That is scientists speak for. We have no idea what is doing this. Some researchers are now asking whether the standard model of particle physics, the framework that explains how all matter and energy behave, might be fundamentally incomplete. Whether there are classes of astrophysical object we have never cataloged. Whether something in the void is accelerating matter through a process our physics does not yet have the language to describe. Think about what that means. We have mapped the observable universe across 93 billion light-years. We have identified black holes at the centers of nearly every large galaxy. We have cataloged pulsars, magnetars, colliding galaxy clusters, and quasars burning brighter than 1 trillion suns. We have built instruments sensitive enough to detect a single photon from 13 billion years ago. And something inside a void, a region where almost nothing should exist, fired a particle at Earth with 20 million times more energy than our most powerful machine. Twice, across 3 decades. If these particles have a source we cannot see, that means there is a physical process or an object that our entire model of the universe cannot currently accommodate. And Amaterasu is not alone. The telescope array has logged other ultra-high-energy arrivals pointing at similar emptinesses. They are still arriving, right now. Somewhere above you, one may be hitting the atmosphere as you watch this. So what is in the void? What has the energy to do this, and why can't we see it? Because if 2 particles can arrive from nothing across 30 years, there will be a third. And whatever sent them hasn't stopped. Drop your answer in the comments. I want to know what you think is out there.